Okay, relations, domain, and range. We've talked about this, and this is actually part one. You did part two, technically, during class today, but it's all the same stuff. So we're going to run through it. What I'm going to start doing to save time on the upload, I'll tell you when to pause it, and I'm going to fill in everything so that it's not sitting here recording me doing everything. So you're going to have to hit pause a lot to make sure you note all these things down, okay? Because uploading anything over about 10 minutes takes almost an hour to convert and upload, so that's not fun. A relation is a set of ordered pairs. Here's where I'm going to hit pause, fill things in, and then flash it back up. Okay, so a relation, that's just another way of saying ordered pairs, your x's and your y's. And you can express those as ordered pairs, as a graph, table, and mapping. Hit pause now to catch up writing. Alright, you're probably going to want to hit pause and copy all this down as you see it. We're relating these things in several of the ways. Part A is the ordered pairs. What I've done is I've just gone over and found the point over here and figured out what the coordinates were and written them down. Then I made it into a table where I listed all the x's and all of the y's. And then I put them into these ovals. And what you'll see is you do not repeat numbers when you are doing mapping. Part C is mapping. Part B is a table. And you can see here with my green lines, and again, it's really hard to draw very straight lines with a tablet, but you can see this 5 as well as this -3 is mapped to that -2. So you'll have more numbers in this x column than you do in the y column because we don't repeat the numbers. Sometimes it might be the other way around. There might be more y's than x's, and you would map the proper set of 2 y's to the proper x. So there you go. Make sure you hit pause to finish. I'm going on. Okay, so now the bottom part of the notes, we have the domain is the set of first coordinates, that's the x's it's referring to. And when we write in domain or range using set notation means we use these little doohickeys. Kind of look like a funky parentheses with a pointy arrow in the middle. That is set notation. Okay, and you'll see that the domain, we list the numbers. We don't repeat numbers. The range, we don't write them down if they repeat, I should say. So do not repeat numbers when writing in domain and range. I just put the D and the R. You should probably put domain and range. Hit pause and finish. Okay, talking about is it a function? Is a relation a function? We are really tested on that. A relation is a function in which none of the x's repeat. So in other words, all of the x's are different. You can repeat the y value and it still be a function, but none of the x's will repeat in order for it to be a function. So in this first example, we have written down the domain and the range, one in yellow, one in green, and it asks the question, is it a function, question mark? And this answer is yes, because none of the x's have repeated. You might want to hit pause if you haven't finished. Okay, so what we have done here is on the second example, I've listed here in domain all of the x values from this list, and I've listed in the range values all of the y values. Okay. If you see, normally we would not write out, in fact, I shouldn't have written in this 1 twice in our x values. So since it is twice in there, this is not a function. The x's have repeated because you see the 1 there and the 1 there. So again, quick way to tell if it's a function, does an x repeat? If it does repeat, then it's not a function. On the bottom example, go ahead and copy that down, and then I will explain it. Well, go ahead and copy it down. The function part that you cannot see, the answer is no, because in this case you can see the x is mapped, sorry, that's not the one I wanted. The x, this number 2, is mapped to a -3 and a 12. That's saying the 2 is repeating. Another way to see that is to see that you can see those two repeated there in these coordinate or ordered pairs. Okay, so the answer at the bottom of, is it a function, question mark? No. And you can write number 2 repeated. Okay, let's go to the next page. And a lot of the ones on the next page we've talked about here in class today, so I'll be just throwing up answers really. Okay, you may want to hit pause and copy these numbers down right quick. And when you've finished copying them all down, hit play again while I explain things. Okay, so on number 5, we've got just a series of points plotted on the graph, on the coordinate plane, and I have just listed all of my x's and all of my y's. All my x's for the domain, all of my y's for the range. Number 6 is like what we worked on today in class. Okay, this is a continuous function, meaning it's a line, and it's got the solid dots. Okay, so that's why I'm using this less than or equal to bit. Again, solid dots mean less than or equal to. Open circles, like down here. Open circles would mean just less than. Okay, and then I just, on the x value, I figured out that the furthest over was -8, and the furthest on the right was a +2, and so that's how I write my inequality in order to show domain and range for a continuous function. Okay, you may want to get ready to hit pause again. Okay, so here we have again a couple of continuous functions in 7 and 8. You'll note that one of the points there is an open circle and one is a solid. So therefore, again, since we figured out that this is -6, -2 for a coordinate pair, and we have 4 and 6 here, you can go ahead and write those on the graph if it helps you. Our domain is -6 less than, open circle, just less than x, less than or equal to 4, because it's a closed circle. And obviously you can read the range and the domain on both. Note that these are both open circles, so we just have the less than symbol, not less than equal to. All right, you may want to hit pause if you have not finished copying all this down. Okay, here we have a couple more. These are the ones where we saw the ray shooting off forever in different directions on these two. Whenever you see a dot, a line, and an arrow at the end, that's saying the ray goes on forever in that direction. It's a geometry thing, but it's also an algebra thing. So this one has a dot at -3, 2. That would be where this dot is on the plane. And so as we go to the right, if you think about walking down that line, your x values would be getting bigger, so I use greater than or equal to. The starting point was -3. And as I walk down that line, my y's would be decreasing, so I say y is less than or equal to a +2. That's at y equal +2. Same idea over here, only my line is going up and to the left. So my x's are actually, I wrote that down wrong. That should be x's less than, again, x's are getting smaller. X is less than 5. And we have on the range, this is, you could write this either way. -2 is less than y, or like I read it in the first place, either way. But as I go up, my y's are getting bigger. As I go up and to the left, my x's are getting smaller. Okay, there we go. We got 3 pages in under 10 minutes. I like doing this pause and write thing. So get on the assignments, please. Bye.